Hello and welcome to part 3 of this series of videos on the unit circle and trigonometric functions. In part 1, we laid the groundwork for everything. We talked about the unit circle, the sine and cosine functions, as well as degrees and radians. At this point, we're mostly working with radians, but it's important to be able to convert between the two. In the second video, we looked at the first quadrant. In fact, I have it right here. We looked at the first quadrant in the plane, so this region over here, and we looked at the values of sine and cosine at the angles of 0, pi over 6, pi over 4, pi over 3, and pi over 2. So we put down our values of sine and cosine in this little table here. I'm going to go ahead and copy those down. We talked about some strategies for remembering these potentially, which you may or may not have found helpful. And in this video, what we're going to do is we're going to introduce the other 4 trig functions that are built out of sine and cosine, and we will discuss their values again in the first quadrant. As I mentioned before, if you understand, let me finish writing before I keep going. If you understand the values of sine and cosine in the first quadrant, you can use those to figure out the rest of the unit circle. In this video, we will discuss how you can use them to find the values of these other 4 trig functions in the first quadrant. And then in the next video, we will discuss how you can use reference angles to find all the trig functions in any part of the unit circle, okay, using what you know about the first quadrant. So as we said, there are 4 other trig functions built out of sine and cosine. The first of which is tangent. Okay, so the tangent, which we denote by tan of theta, what you do is you just take the fraction sine of theta over cosine of theta. Okay, so tangent of theta is sine of theta over cosine of theta. So maybe I'll jot down a quick example here. So like tangent of pi over 6 is just, you take the sine of pi over 6 value and you divide it by the cosine of pi over 6 value. Okay, so what does that come out to? Well, sine of pi over 6 is a half. Cosine of pi over 6 is root 3 over 2. Now, what's going to happen here is you see both the numerator and denominator of this fraction, right? We've got fractions within a fraction. But the top and bottom fraction both have a 2 in the denominator. What's going to happen is those 2's are going to cancel because dividing by root 3 over 2 is the same as multiplying by 2 over root 3, and we get this nice cross canceling. So this actually comes out to 1 over root 3, which you might also see it written as root 3 over 3, okay, depending on your professor, where you look. Either answer should probably be fine, but some professors will prefer not to have irrational numbers on the bottom. So you should probably know both. You should probably understand that these two work the same and just know what your professor prefers. In any case, so the key observation here is that these 2's in the denominator canceled out. So whenever we're computing tangent of theta, we can kind of just think about those numerators, just taking the numerators and dividing them by each other, okay? So we just did pi over 6, and we got 1 over root 3. I'll write it both ways, again, depending on what class you might be in, might determine which one of these you want to use, but they are equal to one another at the end of the day. Let's go back to 0. So tangent of 0 is, well, the nice thing about making our table like this is that we pretty much have our fraction written out for us. Tangent of 0 is just sine of 0 divided by cosine of 0. 0 divided by 1 is 0. At pi over 4, sine and cosine are equal to one another, which means if I have a fraction like 3 over 3, right, the same thing on top and bottom, I just get 1. So that's exactly what happens here. Here at pi over 3, again, we can just take the numerators and divide them by one another because the 2's cancel out, and we get root 3 over 1, which is just root 3. Finally, at pi over 2, ooh, something tricky is going on at pi over 2. We get 1 divided by 0, and we can't divide by 0. So this actually comes out to undefined because we cannot divide by 0. Okay, so tangent of pi over 2 is actually undefined. Kind of interesting. Let's move along to cosecant of theta. That is our next one, CSC, that's cosecant. That is just 1 over sine of theta. Okay, so you just take the value of sine and you just do 1 divided by it. So for example, let's actually skip 0 again because we'll get there in just a minute. Cosecant of pi over 6 is 1 over sine of pi over 6. So we just take this sine of theta and we just take the reciprocal. We just flip it. So 1 over 2, that becomes 2 over 1, which is just 2. Okay, similarly, for cosecant of pi over 4, we're just going to flip the sine value. So we get 2 divided by root 2, which it turns out. So we get 2 over root 2, which simplifies to the square root of 2. Okay, that one I would think you definitely want to just use pi over 2 or root 2 if possible, if you can remember that, just because that is certainly nicer than 2 divided by root 2. But they are both mathematically equivalent. For pi over 3, we are just going to take the reciprocal. We're going to take the reciprocal, so we get 2 divided by root 3 this time, which if you multiply by root 3 on top and on bottom, you get 2 root 3 over 3. So again, depending on your class situation, you either one of they are mathematically equivalent, but your instructor might not want radicals in the denominator. So there we go. For cosecant of pi over 2, well, 1 divided by 1 is, take the reciprocal of 1, you just get 1 again. Now let's come back to 0. Cosecant of 0 is 1 over sine of 0, so that's 1 over 0, which just like we saw with tangent of pi over 2, that's going to be undefined. Okay, so these other trig functions can be a little bit funny. They aren't they don't work quite as nicely in some ways as sine and cosine. Sine and cosine are never undefined, but whenever we start putting them in denominators, we can start running into some problems. Now, secant of theta is just 1 over cosine, and that's going to work very similarly to cosecant. Okay, so I think I'm going to go ahead, fill those in maybe a little bit more quickly. Works the same way as cosecant, as we said. Again, just like you might have seen with sine and cosine in the previous video, we have a little bit of symmetry here. Where if you take this row and reverse it, you get this row. So that's kind of neat. Sine and cosine, they're very intricately related. Very cool stuff. Anyways, so notice that secant is undefined at pi over 2 because cosine is equal to 0 there. The last of these, as you might guess at this point, is cotangent, which as you might have guessed, is 1 over tangent. Now, it can be helpful to break this down into sines and cosines, right? So we're just taking the reciprocal of tangent, so we're getting cosine over sine this time. So again, we're just taking the reciprocals of the things in this row here, right? Well, okay, mostly, right? What is the reciprocal of undefined? I suppose we're not, generally we're taking the reciprocals of these things, right? So cotangent of 0 is going to be, well, cosine of 0 is 1, but sine of 0 is 0. So this one's going to be undefined. Okay. Cotangent of pi over 6 is going to be the reciprocal of root 3 over 3, which is 3 divided by root 3, or just root 3. So that's nice. Cotangent of pi over 4 is going to be the reciprocal of 1, which is 1. Cotangent of pi over 3 is going to be the reciprocal of root 3, which is 1 over root 3, or as we said before, root 3 over 3. Okay. And cotangent of pi over 2, we have to stop and think for a minute about this one. Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this comes out to 0. Okay. Okay, so maybe a couple of comments about these other trig functions. First of all, they can be undefined, unlike sine and cosine. You have to watch out for where the denominator is 0. Again, that's never going to be an issue with sine and cosine themselves. But whenever we start dividing by them, it can become an issue. Another thing to note, so in this first video, we pointed out that sine and cosine are always going to live between -1 and +1, because they are the x and y coordinates of points on the unit circle. Notice that's not true of these other 4 trig functions, right? For example, cosecant of pi over 6 is 2, which is, of course, bigger than 1. And in fact, for all 4 of these other trig functions, they can get arbitrarily large or arbitrarily small. They go off to positive infinity and negative infinity. Okay, so these guys, you have to be a little bit mindful of that sort of thing. Whereas sine and cosine, we know they're always going to be between -1 and +1, not so much with these other guys. I think that's all I wanted to say about these 4 trig functions. In the next video, we'll discuss how to use reference angles to extend what we know about the first quadrant to the other 3 quadrants. And then in the final video, we will discuss the inverse functions of all these guys, the inverse trig functions. Thanks for watching. I hope you're finding it helpful. Make sure you're doing some actual practice. That will be 10 times more helpful for you than watching any video will be. But again, hopefully you got something good out of this.